Okay, so in this video, we're just going to be talking about how to make your own loading icon. And you can do it, we're going to do it with the SVG arc command, and we're going to also do this inside of a React app to manage our state and our animations. Started. So I'll be using Visual Studio Code to do all my programming, and inside there's a nice plugin called SVG Viewer. It's not required, but it's nice to have if you want to follow along with what I'm doing. And lastly, you'll need to have Node installed on your computer as well. So we're just going to talk real briefly about SVG arcs and their properties, and then we're going to make a quick markup example, and then we'll put that in a React component, and then we'll instill that component with some animation and by using trigonometry and repeated calls to component set state, and lastly we'll add on a little bit of rotation with some CSS. So if you want to read in depth about SVGs and in particular paths, this is the reference link that you can follow along with. It's going to be much more in depth than what I describe here, but not only for paths, but for all of SVGs. MDN has a really good reference doc here. So definitely go check that out. But arcs in particular are useful for drawing sections of circles or ellipses. And they require a lot of parameters, but we're going to go over all of them. There's a X radius and a Y radius. There's an X-axis rotation variable, which we're not going to talk about, but as it says, it allows you to rotate your arc around the x-axis with which it allows you to rotate the x-axis with which the arc is drawn around. But then there's a Boolean large arc flag and a Boolean sweep flag, and then an X and Y point, which represents the end of the arc. We're going to touch on all of them, like I said, except x-axis rotation. So let's assume we have two radii and a start point and an end point. And given those four variables, we can draw a section of an arc, or excuse me, section of an ellipsis or circle. But it's not specific enough. We'll say we can actually define four possible arcs in most cases that can stem from these four parameters. So let's just say that we have a Cartesian axis that is 200 by 200, and the center is going to be at the xy coordinate 100, 100. And so this is 0, 0 up at the top left and 200, 200 down the bottom right. So let's define the properties that we mentioned above. Let's say we have a radius of 25 units for both x and y, and we'll start drawing at the xy coordinate 125, 100, and we would end drawing at the xy coordinate 175. As you can see from the image over here, this could produce four possible arcs. Now we can differentiate between those four arcs with the large arc flag and the sweep flag. You can get four total combinations out of using these two Boolean variables, and the large arc flag means it answers the yes or no question: should the arc be greater than 180 degrees or less than 180 degrees? And the sweep flag argument says should the arc be drawn starting in the positive or negative angle direction. So these are just some examples of this is following along with our example, the arcs that we would get providing the large arc flag and sweep flag pairs as such below. So I'm going to pull up Visual Studio Code, and we're actually going to generate these live. What I'll do, so before I do this, I mentioned I have an extension called SVG Viewer. If you just search for it in the extensions tab, it should be this first one here. It allows you to select an SVG that you're building, and you can preview it within Visual Studio. So I have that installed. You can see those extensions down here. So I created a small SVG file called arcs.svg, and inside it I'm defining what I just talked about in the presentation. So let's back up a few slides, and we'll kind of do a one-to-one here. So I've defined the SVG with as a box that is 200 by 200. And it's going to have a arc inside of it that starts its drawing at 100, or excuse me, it starts its drawing at 125, 100. And we have an arc command that has the x radius of 25 and the y radius of 25. We're not going to touch the x-axis rotation, large arc flag, or the sweep flag just yet, but we'll stop drawing at 175. And then lastly, we'll give it a little bit of stroke so that it has color, and we will set the stroke width to be something like 5, and we're not going to fill the inside of the arc. We just want to see the arc and the arc alone. So if I hit the view SVG here, let's move this over, you can see what we got out of this. Now, if I make 3 more of these and color them like I did in the PowerPoint, purple, blue, and green, we can actually see if we modify the large arc flag and the sweep flag, we can see the 4 possible arcs that we could get from just this one command here. So now we'll move over into a React app where we can actually control these values and see, instill it with a little bit of animation. So we don't need these 3, so we're only going to be using 1. And we're going to open up the folder that this is in, and we're just going to open up command prompt, and we're going to run the command npx create React app, and we'll just call it SVG loading example. So I'm going to let this install, and I'll just fast forward a little bit until that installation completes, and we'll pick up where we left off. Okay, so that just finished on my side. So I'm going to do exactly what they say here. I'm just going to cd into that directory that just got created and run the npm start command. And this is just going to create a local development server for me, and I can write React code, save it on the fly, and just see the updates in the browser. So let me pull that window over. This one. There you go. So this is what you should see. So what we're going to do to start here, I'm going to close out of this preview. I'm going to go into that this app.js file, and I'm going to delete all the stuff that we don't need. So if we go back to our React app, it should be empty. Get rid of this, and I'm going to open up the CSS file and comment out the background color so we can have a white background. Next, what I'm going to do is I'm going to take this SVG code that we wrote, and I'm going to stick it right inside the React app, format it a little bit, tab it over, there you go, and save it. And then if we go in, we should see our arc. Perfect. So the first step in this process, actually what I'm going to do is make this a class component. So for default class app extends, and we're going to need to import React to do this. Okay. Now since this is a class component, we're going to need the constructor. And for now, we'll just leave this blank. We'll use that shortly. Lastly, we need a render function which returns 1 here. Let's tab over, do that, go to the bottom, boom. Now this should be exactly the same, but now we're using a class component instead of a functional component. So in order to do this, what we're going to want to do is actually create an interpolated string, because we're going to manage these values with state, and we're going to constantly update state in order to see our animations. So in order to do that, let's just do this real quick and make this multi-line interpolated string. Now we're going to need to manage these things in the arc command. So just from left to right, we'll say we're going to manage Rx. We'll start with 25. That will change shortly. Start with Ry, and we'll do, so we're not going to manage the x-axis rotation, but we are going to manage the large arc flag. And we're also going to manage the sweep flag 0. Lastly, our end is going to be 100, and our y for the end is going to be 75. So we can destructure these from state. And we can interpolate them within our string down here. Our y, this is going to be that large arc flag. This is going to be the sweep flag, and this will be our x, and this will be our y. Okay, so to save this, go back to the app. See, nothing has changed. That is desired. So now let's do a little bit of animation with this. So we are going to make an animate function, and we are going to call this animation on the mounting of our component. And so let's do some very basic animation stuff to start, and then we'll cover a few more base cases as we go, or a few more edge cases as we go. So we're going to need a few things from our state. We're going to need, for now, let's just do Rx and Ry. And we're going to need to manage an angle, which will represent, which we'll use to calculate the endpoint of our arc. So let's just say that angle starts at 0. Now every time we call animate, we're going to say, let's get the angle in here as well. Every time we call animate, we're going to calculate a new angle, which will be our current angle in state, plus, let's do math.pi over 180. And we will say our new x and our new y. Well, so before I do this, let's define another piece of state, which is our center, which we said was going to be at 100, 100. So let's say our new x value is going to be Rx times cosine of our new angle. And our new y is going to be similarly sine of the new angle. Now this will give us what we want if we are centered at 0, 0, but we are not centered at 0, 0. We are centered at 100, 100. So we'll just add a little center x and center y shift to these values. And then we'll do a set state call to update this. We'll carry over our new x, our new y, and our angle is going to be a new angle. Now, if I save this, we'll say center is not defined. Okay. oh, that's right, because I forgot to destructure it from here. Save that and reload it. So you'll see this very small sliver in here, and that makes sense with what is happening, because the component mounts we call animate, and our angle, which is 0 to start, becomes math.pi over 180. We calculate these new endpoints. We trigger set state, which would then cause a re-render, and then we're drawing something from 125, 100 to whatever 25 times the cosine of, math pi over 180, which is going to be something very, very, very small. Same with the sine. So in order to see some animation, we're actually going to need to do some repeated behavior here. So we're going to use the native set timeout call, and we'll pass it the animate function, and we'll call it every 15 seconds or 15 milliseconds. So as you can see, we're seeing a little bit of animation going on here. This is good, but it isn't quite exactly what we want. There's a few things we need to change in our animation function, specifically regarding the sweep flag and the large arc flag, and we can do a little bit of angle cleanup too. So for starters, let's go to this new angle here. So we're dealing with trigonometry here, and the circle is 2 pi periodic, or the cosine and sine functions are 2 pi periodic. So in order to just kind of have this wrap around, so we get the same set of angle values over and over again, we can put a cap on new angle. And so if we say that if the new angle is greater than or equal to math.pi over 2, what we can do is just reset that angle back to math.pi over 180. And this shouldn't really change our behavior all that much, but what'll happen is we're just getting the same values every time this animation finishes and comes back to repeat. So we want to modify the large arc flag and the sweep flag in order to get this arc that we're actually shooting for here. So let's start with the large arc flag. Now, we don't really need to pull this out of state. It only depends on the angle that we're at. So we can set this new large arc flag based on our new angle. So we can say if the new angle we have is greater than or equal to 0, and the new angle is less than math.pi, we will say that we will want to draw this large arc flag when this is true, and we will not want the large arc flag to be there when this is false. So if we go back in here, we can see that now, whenever we are drawing this arc, we are getting a more contiguous thing because we are drawing the large arc flag half the time, and we're not drawing it the other half of the time. And the time that we are drawing it is when our angle is between 0 and pi, which, if we just comment this out real quick, is at the start of the animation. But now at the end of the animation, we actually don't want the larger portion of the arc. So if we turn that back on, you can see what I'm talking about. We're getting the large arc now, and then right once it hits this point here, we don't want that large arc anymore. So the sweep flag, we can actually use the sweep flag to change the behavior of this arc that we draw. And by changing the sweep flag, we can actually get the arc to look like it is opening and it is closing. So in order to do that, let's just pull the sweep flag out of state. And in here, we'll say our new sweep flag is going to be this SF variable. And then we will put the sweep flag down here. So we shouldn't really be changing anything right now because we're not changing the behavior of the sweep flag. But let's think about what we want to do to this sweep flag, right? So it's a value of 0 or 1. And we want the angles to be drawn here to start in the negative direction the first time, but then we want to change those around so that they are in the positive direction when we come back around. So this behavior is going to change each time the arc comes all the way back around to 0. So what we'll do is we'll just say in this function, we will change the sweep flag every time we come around to, every time the angle wraps around, which is basically this conditional right here. So if we give this a look, we can see what happens. Now, the arc comes back around. So whenever the arc comes back around, we are drawing this big arc, and then the arc goes from big to small. Now, we don't want to draw a big arc at the start. We want to draw a big arc at the end. So we can use this sweep flag math to determine the large arc flag. And it's actually just going to be the opposite behavior of what we want when the sweep flag is 0. So we can do another inline ternary operator here. So we'll say if our sweep flag is 0, we're going to define two behaviors. First one is going to be when the sweep flag is 0, and the second one will be when the sweep flag is 1. So this was our sweep flag 0 behavior. Let's just stick it in there. But now we want the opposite to happen, right? Because, all right, let's wait for this to come around. Whenever this comes around, we don't want to draw a large arc. We actually want to draw a small arc. So if we just alternate those two behaviors, go, we give this a save. We can see this come around, and right once this finishes, it picks up where it left off, and we'll come all the way back around, and now it will change again. So you saw that little flash there. So what's happening is we're going all the way up to math.pi over 2. Or excuse me, we're going over to 2 times math.pi with this angle here. So right, if we had an angle of math.pi times 2, we'd be drawing something from this point here to that same exact point. So in order to preempt that a little bit, and you can actually kind of see the angle is just ever so slightly off in there. We can preempt this by just saying math.pi over 180. So we will stop drawing the circle right before we touch it, but don't touch it completely. Because if you draw an arc from one point to the same point, you're going to get nothing. So that's why we see that little blink there. So this is just a live example. So it's going to come around. And right before it hits that point, we're going to just not do that last arc calculation, and you don't see that flicker anymore. So this is nice. This is good. But we can do a little bit of extra stuff to kind of spice up the behavior. So the first thing that I'm going to do is I'm going to go in app CSS, and I'm going to give this class name. Let's call this our loading icon. And I'm going to go over in here, and the loading icon, let me copy and paste it. The loading icon is going to get a transform, and I'm just going to spin this I'm gonna spin this around the z-axis so that the loading starts to happen kind of from the top of the circle instead of the side of the circle. So let's just do a rotate z, and we'll just do a an angle. I'm guessing it would be -90. Just refresh. So transform, rotate. Am I using that correctly? Let's say -90 degrees. There we go. So now you can see, let's just give this a refresh. You can see it's starting from the top of the circle, coming down, and then it's coming back around. So like I said, this is good. This is nice, but this kind of static behavior, this is not the behavior you see with a lot of loading icons. You kind of see this bar, this arc, move slowly towards the top when it's, barely open or, barely closed. And then whenever it's farther away, you kind of see it chasing, kind of chasing to get back to the center point here. So we can implement this kind of chase in a few ways, either by increasing our the angle that we increment by every time, or we can modify the timeout with which we redraw. So I'll just do the timeout modification. So we can make a variable called chase, which is going to represent the new timeout. And this timeout is going to be based on the angle that we're at. So we can get a distribution of values between 0 and 1, given this little like normalization formula. So we can say I want the absolute value of our new angle, and we're going to be changing the timeout based on where we are in the rotation, and we want the timeout to be very little when we're down here, or just instead of very little, we want it to be quicker when we're down here versus slower when we're up here. So we can say this new angle, depending on how close it is to math.pi, we can kind of get this idea of chase, and the chase is going to be we want it to be a value, right? So this is going to give us something between 0 to 1, but we want this to be on like a reasonable timeout. We don't want very small millisecond timeouts. Let's just say we want our chase to be multiplied by 100, right? So this is going to take our range and make it 0 to 100. And then after that, we will divide it by 10 to get a range from 0 to 10. And then after we do this this floor here, we can add 5 to this, and so this will effectively give us a range of values between 5 and 15. So if we then replace this variable here with the chase that we've described, you can see this accelerate quickly when it's farthest away from this starting point, and you can see it go slower when it's close to the start here. Now this is kind of a linear change in chase, so the chase is like, the difference between the chase here and the chase here is the same as the difference between the chase here and the chase here. So if we want to kind of exaggerate the behavior of this, we can square or multiply our chase by a new value by itself a few times before we do that, flooring and whatnot. And what that'll do is that'll give us a quadratic or a cubic distribution of values, which will tend to increase quicker instead of increase a little bit slower. So we can get a more drastic or more obvious change in chase for that value. So what we can do is just tag it on to here. Let's just do a math.pow. This value that we just calculated. So let's actually do this. And let's just do to the power of 4. So this would be like a quad or a end of the fourth distribution of values, and you can see how it more aggressively chases quicker and slows down in a shorter period of time. So you can do all sorts of like cool stuff here to calculate this chase value. So you can really fine tune the behavior of the arc that you want. But the last thing that I'm going to do is this is actually something that they include in the React app right out of the start. This app logo spin animation. So if we just change that class name to be the one of our actual icon, we are actually going to just piggyback off of that React app spinning behavior, and we can actually get like a spinning loading icon. 20 seconds is pretty slow, for example, so I'm just gonna knock it down to 2 seconds, and you can see now we get a nice pretty loading icon that makes a full rotation every 2 seconds and is doing its own thing off to the side. So yeah, that's basically it. And you can do all sorts of stuff to make this component really fine tune it. You can mess with the chase, you can mess with the angle with which you increment by, and again, this is all a React app, so you can pass in some props for the color or how wide you want this to be, and we'll just call it there. So yeah, there you go. So you can take this component and run with it, do whatever you want, but you don't have to import any extra libraries. You can just do this all on your own now. So I guess that's it. Thanks for watching.